Hello, and welcome to the Digital Spiffy YouTube channel. This video is the sixth in a series covering the material on the CCNP ENCOR exam. I will be using physical Cisco equipment to lab the material. The lab material is sourced from the CCNP ENCOR Lab Manual version 8. I highly recommend reading the CCNP Enterprise Core 350-401 official cert guide in conjunction with this lab material. This will provide a better understanding of the labs and what is occurring on the equipment. You can find links to these books in the description below. This video will cover Dynamic Trunking Protocol and EtherChannel protocols. DTP assists with provisioning trunk links between switches, while EtherChannel is a method of adding bandwidth and suppressing topology changes from link failures. Cisco provides a mechanism on their switches for ports to become trunked ports dynamically. Dynamic trunk ports are established by the switch port sending dynamic trunking protocol packets to negotiate whether the other end can be a trunk port. If both ports successfully negotiate an agreement, they will become a trunked port. DTP sends advertisements every 30 seconds by default. Neighboring switches will receive this advertisement on connected ports, but must share a VTP domain to form the trunk. This feature works out of box with Cisco switches, as the VTP domain is blank by default. Dynamic Trunking Protocol has three modes. Trunk statically places the switch port as a trunk and advertises DTP packets to the other end to establish a dynamic trunk. You can set this mode in the interface config with the command switchport mode trunk. Dynamic Auto. The switch port acts like an access port but listens for DTP advertisements. No advertisement will be sent out of this port. When a DTP packet is received, the port will go through negotiation for a trunking protocol, and the trunk link will be established dynamically. You can set this mode in the interface config with the command switchport mode dynamic auto. Dynamic desirable. The switch port acts like an access port, but listens for neighbors' advertisements as well as sending advertisements for DTP. When a DTP packet is received, the port will go through the negotiation for a trunking protocol, and the trunk link will be established dynamically. You can set this mode in the interface config with the command switchport mode dynamic desirable. A trunk link can successfully form when ports are set up in any combination except when both ends are configured with auto. No advertisement would be sent, so neither port would establish a trunk. A static trunk port attempts to establish and negotiate a trunk port with a neighbor by default. However, the interface configuration command switchport no negotiate prevents that port from forming a trunk port with a dynamic desirable or dynamic auto switch port. Cisco best practice is to set each port as a static trunk or access port. As discussed in Chapter 2, a reliable network provides redundancy. Multiple switches and multiple links between them safeguard a network from a single point of failure. Redundancy is considered best practice, but requires specific configurations to prevent network loops. However, redundant links don't have to be blocked by STP. We can use EtherChannel to utilize the bandwidth while providing redundancy from link failures. An EtherChannel bundle is also known as a port channel. Working as a Cisco network engineer, you will use and work with port channels frequently. EtherChannel is defined in the IEEE 802.3 AD link aggregation specification. EtherChannel can also be used for Layer 2 or Layer 3 forwarding. A primary advantage of using port channels is a reduction in topology changes when a link goes up or down. A switch can successfully form an EtherChannel by statically setting them to an on state or by using dynamic link aggregation protocol to detect connectivity between devices. A significant downfall of statically setting an EtherChannel to an on state is that there is no health integrity check. If the physical medium degrades and keeps the line protocol in an up state, the port channel will reflect that link as viable for transferring data, which may not be accurate and would result in sporadic packet loss. There are two common link aggregation protocols. Port Aggregation Protocol, PAGP, is a Cisco proprietary protocol. It can only be used between Cisco devices, and messages are always sent to the well-known Cisco multicast address. PAGP uses the same multicast group MAC address of CDP, Link Aggregation Control Protocol. LACP is an open industry standard. It advertises messages with the multicast MAC address 0180C2000002. LACP works with Linux, Windows, and other non-Cisco switches. LACP is frequently used in real-world networks. In the first part of this lab, we will set up a network topology and configure basic settings and trunks for VLANs. I've saved the configuration in a text file and uploaded it to my website, digitalspiffy.com. You can find the link to download this and other related files in the description below. For this lab, I'm using physical 3750 Cisco switches on version 12.2. On the D1 switch, I'll configure hostname and configure the line console to prevent timeout and the output from displaying over our terminal. I'll run 2 show commands and we can verify that our default port config is placing us in VLAN 1 and our DTP is set to auto. The DTP status of auto means that if both ports on both sides are set to their default config, the trunk link will not form. The D2 and A1 switches will start off with the same configuration. I'll just copy and paste that from my configuration file. Once this is done, I'll run the show commands on A1 and we can verify what we see on D1. The ports are configured as default, and so we see the trunk port did not form. DTP is used by Cisco switches to automatically negotiate if a port should be an access or trunk port and which trunking protocol to use. On the A1 switch, I'll change the DTP mode of the interface Fast Ethernet 105 to Dynamic Desirable. This is done in the interface config, and I'll give it a second and run the show interface trunk command. You can see that the trunk is formed. D1 port 105 is DTP auto. And A1 port 105 is DTP desirable. On the other port that connects D1 to A1, I will change the trunk to be statically on. On the D1 switch interface 106, I'll set the encapsulation mode to .1Q, as this switch supports ISL as well. Then I will issue the command switch port mode trunk. With the show interfaces trunk command on D1, you can see this port is now a trunk. On A1, I'll run the same show command and confirm this trunk is up and the DTP mode is set as auto. DTP is not secure. An attacker could send a false DTP packet and cause a switch port to become an unauthorized trunk port, giving the attacker access to all VLANs allowed on the trunk. Cisco best practice is to set the mode statically and deactivate the DTP protocol on a port using the command switch port no negotiate. On A1, I'll shut down the ports that connect to D1 and then I'll configure them as trunk ports on both switches statically and disable the DTP negotiation. I'll bring the ports back online. I'll run do show interfaces Fast Ethernet 105 switch port, pipe include mode, and verify that the trunk was established statically under the operational mode. I'll also run show interfaces trunk to verify the trunks are online. Before moving on to the next step, I'll configure the ports back to the default using the command default interface range fast Ethernet 105 through 6. On D1, D2, and A1, I'll configure all the connected ports as trunk ports statically. In this next step, we will configure an EtherChannel without a negotiation protocol. This is against best practice because there is no health check mechanism when the port channel is statically set to on. Switch 2 will use interface 107 and 8 to connect to A1. First, I'll set these ports to use .1Q and statically to trunk ports. Then I'll turn off DTP negotiation, verify the trunk ports have been formed, and now we will statically set the EtherChannel on with the command channel group 1 mode on. Verify the EtherChannel has been formed with the command do show EtherChannel summary. You can see our port channel is a layer 2 port channel in use with interfaces 107 and 8 bundled in the port channel. On A1, I'll issue the command do show spanning dash tree. Currently, there is no port channel. So we configure that port channel. Rerun our spanning tree command. And you can see the port channel exists. Changes to EtherChannel should be done on the port channel. On D2 and A1, I'll create VLAN 999 and name it the native VLAN. I'll configure that native VLAN on port channel 1 for each switch. Now that we know about statically assigning EtherChannel, we can test out the Cisco proprietary PAGP. PAGP works between Cisco equipment only. Just like with DTP, the two modes of PAGP will help form an EtherChannel. Desirable actively communicates the desire to build an EtherChannel bundle, where Auto passively agrees to a bundle negotiation if presented. Just like DTP, if both sides are set to Auto, no negotiation will be made. On D1 and A1, the connecting ports have been set to use .1Q and are statically set to trunk ports. DTP negotiation has been turned off, and now we can verify the trunk ports have been formed with do show interface trunk. After we have confirmed the trunk ports between switches D1 and A1 are formed, we can create a PAGP EtherChannel. On A1, I'll interface the two ports that connect to D1 and create channel group 2 in the mode desirable. I can use the non-silent option at the end. This is configured to keep PAGP from automatically forming bundles with non-PAGP devices like file servers. In the final part of the lab, we will use LACP to establish the EtherChannel. LACP is an open standard and operates in either active or passive mode. The active mode actively communicates a desire to build an EtherChannel bundle, where the passive mode will passively accept any negotiations directed towards it. If both sides are passive, no EtherChannel bundle will form. On D1, I'll interface the range of ports that connect to D2. We can verify the trunks have been formed with the do show int trunk command. Ports 1 through 4 are statically set to trunking and online. On D1 in the config for the interfaces that connect to D2, I'll create the channel group 3 and set the mode as active. Before I do the same thing on D2, I'll show you that the ports on D1 are waiting to be aggregated by examining the output of the do show EtherChannel summary. On D2, I'll interface the range of ports that connect to D1 and set up the channel group. To show you that the channel group number is locally significant, I'll set it to the switch's maximum, which is 48. You should now see an EtherChannel in the do show EtherChannel summary output. On D1 and D2, I'll change the native VLAN to 999 to the corresponding port channel. Thank you for watching the Digital Spiffy YouTube channel. This video is the 6th in a series covering the material on the CCNP ENCOR exam. In this video, we explored dynamic trunking protocol and EtherChannel protocols.